Good morning, dear students. In last lecture, we have seen the solution till question number 1 of exercise 4.2. Today, we will start with question number 2. Here, we are asked to find the value of this determinant without actually expanding it. So, we'll try to find the relation between columns. As you can see that if I observe column 1 and column 3 carefully, then both of them is having a in common, and that too of opposite sign. Here it is plus a, here it is minus a. So if I add column 1 and column 3, then a will get removed and we'll get the relation between b and c. And if you will observe that column 2 is having b, the relation between b and c. So this gives me the idea of adding column 1 and column 3. So I will apply property 6. Column 1 gives column 1 plus column 3. This property says that the resultant of column 1 plus column 3 will be kept in column 1. So in column 1 I will add column 1 plus column 3. The same way, column 1 plus column 3. Column 1 plus column 3. We'll write column 2 and column 3 as it is. Here you can see that A is getting cancelled over B and B is getting cancelled, and here C and C is getting cancelled. So I am left with C minus B, A minus C, B minus A. Here B minus C, C minus A minus B, C minus A minus B. I have kept this column 2 and column 3 as it is. You can see that, right? I have just note down the solution of this column 1 over here. Now if you can see that column 1 and column 2 are actually same, just the sign of the elements are opposite. You can see that over here B is positive, here B is negative, whereas here C is negative, here C is positive. To make this column 1 and column 2 same, I will multiply column 1 with minus 1. But you know that to apply this property, we have to counterbalance the step. Means if I am multiplying minus 1, then I have to divide minus 1 outside. Now if I multiply this column 1 by minus 1, then I will get B minus C, C minus A minus B. My column 2 is also B minus C, C minus A minus B. Right, so you can see that column 1 and column 2 are identical. Both of them are identical. Therefore, the value of this determinant will be 0. You can write it in comment that column 1 is equal to column 2. Therefore, the answer of this determinant is 0. Let's start with question 3. Here also, we need to find the value of this determinant without actually expanding it. Here also we need to find some relation between columns. As you can see that the nearest multiple of 7 is 63. That is nearest to 65 is 63. 7 9s are 63. So if I subtract 65 minus 63, then I will get 2. Yes. So let's take this logic, whether this applies for remaining two elements also or not. So if I multiply this by 9, then I will get 72. If I subtract 75 minus 72, then we'll get 3. And if I multiply this by 9, we'll get 81. Subtracting 86 by 81, we'll get 5. Yes. So this gives me that idea that I should write column 3 as column 3 minus 9 into column 2. Yeah. So here column 1 and column 2 will remain as it is. Column 3 minus 9 into column 2. 9 sevens are 63, 9 8s are 72, 9 9s are 81. So if I write the solution of last column, or if I solve last column, then it is 2, 3, 5, and the value of determinant is 0 because so column 1 is equal to column 3. Let's understand the fourth question. I will first of all multiply this monomial with a binomial using distributive property. I will get AB plus AC. Here BC plus AB. Here AC plus BC. Right. So if I add second column in third column, then I will get AB plus BC plus CA. AB plus BC plus CA. AB plus BC plus CA. All the three elements of the third column will become same. So here I will apply column 3 gives column 3 plus column 2. I will add column 2 in column 3. We will write column 1 and column 2 as it is, and my third column will become AB plus BC plus CA. AB plus BC plus CA. AB plus BC plus. Now I will take common from third column, this whole term AB plus BC plus CA. Now to take this term common, we have to pass one rule, and the rule is column 3 gives column 3 divided by AB plus BC plus CA. And you know that if I am dividing something, then I have to multiply that same number outside. So if I am dividing column 3 by AB plus BC plus CA, I have to multiply AB plus BC plus CA outside. 1 1 1 BC CA AB. This is divided by AB plus BC plus CA, answer is 1. This is divided by AB plus BC plus CA, answer 1. This is also divided by the same number, answer is 1. And the value of this determinant is 0, as column 1 is equal to column 3. So 0 multiplied by anything is 0. Let's understand the fifth question. We will start with the left hand side of the given question and will proceed towards the right hand side. As you can observe that your given right hand side is a monomial, means the entries in the determinant are all monomial, whereas in the left hand side the entries are binomial. So I have to convert this binomial into monomial. Now looking to the symmetry of rows, here C is given, here A, here A is given, and that two are of the same sign, plus C plus C plus A plus A. So to get monomial, we'll subtract row 1 minus row 2 minus row 3. So B plus C minus C minus A minus A minus B. Q plus R minus P minus P minus Q. Y plus Z minus Z minus X minus Y. Rest all will be same. C plus A, R plus P, X plus Z, A plus B, P plus Q, X plus Y. Right. So here plus C minus C plus B minus B will get cancelled. Plus R minus R plus Q minus Q plus Z minus Z plus Y minus Y. So here we are left with minus 2A minus 2P minus 2X. The rest will be same. C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. So first column got converted into monomial, right? Not column, first row got converted into monomial. Now we'll take 2 common from row 1. Now to take 2 common from row 1, I will pass one rule. Row 1 gives row 1 divided by minus 2. Right. We'll rub this as we don't have enough space. Right. As I am dividing row minus 2, I have to multiply minus 2 outside. This is A, P, X. C plus A, R plus P, now if you can observe, here is a, here also A, here P, here X, and that go of same side. So if I pass this rule, R2 gives R2 minus R1, then this A will get cancelled, this P will get cancelled, and this X will get cancelled. So minus 2 into this is A, P, X. C plus A minus A, just C is left. R plus P minus P plus P minus P got cancelled, and we are left with R. Z plus X minus X plus X minus X got cancelled, and we are left with just Z. Right. Third row will be as it is. Right. Now if you can see that here also it is a P, P, X, X. So if I apply, row 3 gives row 3 minus row 1. then a plus b minus a, just b is left, p plus q minus p, just q, x plus y minus x, just. But you can see that still we are not getting our right hand side. That is because here row 3 is row 2 in right hand side, and here row 2 is row 3 in right hand side. So I will apply R2 will interchange with R3, and I told you if you want to apply this property, then you have to change the sign of determinant. Here the sign of determinant is -2, so I will write +2, so 2, and I will interchange second row and third row. So my answer is AP, X, B, Q, Y, C, R, Z, and this is our right hand side, hence proved. Let's start with the sixth question. In matrix, this type of matrix is called a skew symmetric matrix. I will explain that skew symmetric matrix in that chapter, but to understand or to just know that whether the given determinant is a skew symmetric determinant or not, then you should observe their principal diagonal carefully. Always skew symmetric determinant will have their principal diagonal 0, and the element in the upper triangle and lower triangle will be same with opposite sign. As you can see that if it is A, over here it is minus A. If it is minus B, here it is plus B, minus C, plus C. Right. So this type of determinant is called skew symmetric determinant, where the values of principal diagonals is 0, or the elements of principal diagonal are zeros, and upper triangle and lower triangle are exactly additive inverse of each other. To find the solution of this, we'll apply some different approach. Right. We'll apply Ri to Ci over here. Ri to Ci. This properties says that you should convert every row into column. Therefore, my first row will become my first column. My second row will become my second column. Third row will become my third column. Right. Now I will multiply row 1 with -1, row 2 by -1, and row 3 also by -1. As I am multiplying -1, I have to divide -1 outside. Multiplying row 1 with -1 will give me 0, plus A minus B, minus A is 0, minus C, B, C, 0. The value of this is -1, whereas the value of this from equation 1 is D only, right? So minus D, if it will come on left hand side, it will become plus D. So D plus D is 2 times D. 2D is equal to 0. So value of D is also equal to 0. Let's understand the 7th question. Here we are starting with the left hand side and we'll move toward right hand side. Means finally I will get right hand side. If you can observe your first row, then you are having A in common. If you observe second row, then you have B in common. And if you observe third row, then it has C in common. So I will apply. Row 1 gives row 1 divided by A, row 2 gives row 2 divided by B, and row 3 gives row 3 divided by C. As I am dividing A, B and C, I have to multiply A, B and C. I am dividing row 1 by A, then the answer is minus A, B, C. If I am dividing row 2 by B, then answer is C, B, C. I think I wrote wrong question right. Here it is BA, not BC. Here it is BA, right? So if I divide this by B, then here I will get A. Now if I divide that row 3 by C, then I will get A, B minus C. Here also I will get minus B, not plus B. Right. Now if you observe column 1, column 2 and column 3 carefully, then A is common in column 1, B is common in column 2 and C is common in column 3. So I will apply this rule. Column 1 gives column 1 divided by A, column 2 gives column 2 divided by B, and column 3 gives column 3 divided by C. As I am dividing ABC, I have to multiply ABC outside. Already one term of ABC is present, so I will get A square, B square and C square. Here minus 1 1, 1 minus 1 1, 1 1 minus 1. I will expand this. You can still make zeros by adding row 2 and row 3, but you can directly expand also if you wish to. So I will directly expand this. Minus 1 into 1 minus 0, not 0, 1 1s are 1, right? We'll change the sign of second element. Minus 1 minus 1 plus 1 into 1 minus minus 1, right? So A square, B square, C square, 1 minus 1, 0. Minus 1 minus 1 minus 2. Minus 2 into minus 1 will give me plus 2. Minus minus plus 1 plus 1 2. 2 ones are 2. So 2 plus 2 will give me 4. So final answer is 4A square, B square, C square, which is your right hand side. Hence proved.